There we go with another IGCSE question. Now, first one, find a fraction n that satisfies this inequality. So we have here n is greater than 5 over 7, but it's less than 6 over 7. So how can we find a number that's in between those two? Well, if you remember, when we have a fraction, we may multiply on top and below by the same number, and it should still be the same fraction. Nothing has changed. So that perhaps would be a good technique for this first question. So this first number, 5 over 7, is the same thing as 10 over 14. If you simplify, divided by 2 on top and below, on the numerator and denominator, you would get back to 5 over 7. Now we can do the same thing with the other extreme. So 6, if you multiply by 2, you would get 12. And 7, if you multiply by 2, you would get 14. So, which number would be between 10 over 14 and 12 over 14? 11 over 14. Letter B. Write down an irrational number, m, that satisfies this inequality. So m should be between 4 and 7. Now let's think about this for a while. We are looking for an irrational number. So an irrational number is not a rational. So not rational. Rational numbers are numbers that we can write as a fraction. So basically m, if it was rational, right, you would be able to write it as a over b, and a and b would be integers. If it's not irrational, so if it's irrational, you cannot write it as a fraction. And usually, numbers that we cannot write as a fraction, a very good example are surds. So root of 2, root of 3, root of 5, root of whatever. Anything that is a prime number, 7, 11, 13, and you can keep going. Now, however, there will be some of those roots that we know. For example, if we keep going here until our root of 16, we know that this is 4, which is one of the extremes that we have here. If we keep going, which would be the root that would give us 7? It's root of 49. There are other numbers as well, here in the middle, which would give us roots that we can calculate. For example, 25, which gives us 5, and 36, which gives us 6. So in fact, we can get any number that is a root that we cannot solve. So for example, if I was to get roots of 17, 17 is a prime number. So I won't be able to actually solve this. I can even show you on the calculator. So if we do square root of 17, we get 4.123105626. Now, the thing is, this number does not stop there. It keeps going. However, it is, well, it's truncated or rounded because the calculator cannot show us, well, there's a limit to how many digits the calculator can show us. So it has to stop somewhere. So I cannot give you a precise, definite answer. What I can tell you that there are several possible answers. Any number that you get in a root that is between 16 and 49, and you cannot fully factorize, so there will be some surd, could be here. So I don't know, let's get a number. Let me choose a number. So what about 42? 42, well, if I get the root, it would be between those numbers. So it should be between those. However, I have to check if it would produce some surd. So 42, I can divide by 2, which will give me 21. I can divide by 3, which gives me 7. And I can divide by 7, which gives me 1. 2 times 3 times 7 should give us back 42. There you go. However, if I try to extract the root, all of those show up only once. So they are all trapped inside of our square root. So 42 would also be a possible answer, because it is between 4 and 7, and we can get the root of 42. And see? Just like the other number that we had before, root of 17, that root of 42 is shown just up to a certain degree of accuracy. That number, in fact, continues endlessly. And that's why it's an irrational number. You would never be able to write the actual number as a fraction. You could get this rounding that you have here and write that as a fraction, because it is an approximation of what that number actually is. However, you would not be actually writing the number itself as a fraction. You would be writing a rounded version of it. So the actual number, root of 42, or root of 17, or any surd, is an irrational number.